All right, Algebra 2 students, I am making this video as a how-to on how to compare exponential and linear functions in case you're stuck on this IXL workspace. So the first thing is the function f of x is written in an exponential form. I'm going to pull up my pen tool here. So this is in an exponential form where I have a times b to the x. So in this case, b is equal to 5, and that means that this function is multiplying by 5 each term. That means that the a value, if I don't see anything there, the a value in this case is equal to 1. So since I don't see a number in front of 5, we're going to actually start this function out with 1 as the 0 term. So the a value in this case is the y-intercept. Let me write that here, y-intercept. And the b value is equal to like my rate of growth in this case. So when I'm looking at this, I'm starting with 1, and I'm going to multiply by 5. So 1 times 5 is 5, and then 5 times 5 is 25, and then 25 times 5 is 125. As a reminder, the g of x function is a linear function, and so this is in the form of mx plus b, where the b value in this case is equal to 3, and that is representing your y-intercept. And the m in this case is the slope of 6, and so that's your rate of change. And that implies addition. So we are adding 6 each time or each consecutive term. So in this problem, I'm going to start at g of x at the y-intercept of 3, and then I'm going to add 6 consecutively because it's a linear function. So 9 plus 6 is 15, and then 15 plus 6 is 21. So obviously the f of x function, which is a exponential, is going to grow faster than the linear. So the f of x, or 5 to the x function, is the one that grows the fastest. So in each of these cases, you're going to kind of do the same thing. Another thing you can do is you can actually substitute in these terms, these values, in for x, and you can evaluate them that way. So in the f of x function, I could do 4, since the first term is x equals 1. I could do this as, sorry, I need my pen. Okay, I could do this as 4 times 1 plus 5, and then 4 times 2 plus 5, and 4 times 3 plus 5, and 4 times 4 plus 5. Now, for this linear function,
Michael Malley, if you are still in the building,
sorry, I'm recording at school as they're making announcements before the snow day. So going back to this, 4 times 1 plus 5, I can put in obviously these terms and do 9, and then I could do 13, and I know that these are going to increase by 4 because that's the slope of the function. 21. Now with the g of x function, this is where, like, because the g of x looks a little bit different, that there is a shift in this one. This is where maybe using that input output situation makes this a little easier. 4 to the first is 4, minus 5 is negative 1. 4 to the second minus 5 is 16 minus 5, which is 11. Sorry. And then 4 to the third. So this gets big relatively quickly. 4 to the third is 64 minus 5 is 59. And then 4 to the fourth power minus 5. I believe it's 256. Minus 5. And let me actually double check. So I would pull up my Desmos calculator. And so 4 to the fourth, yes, 256. And so 2 to the 56 minus 5 is 251. So obviously, again, the exponential is growing faster in 251. So I would choose the exponential function. So that's the gist of this this lesson, just comparing the linear and exponential growth, paying attention to what the b-value is or the growth factor in the exponential, because that's going to make a difference.